Are they finding some inconsistencies? 11.5. Let's take a look. So 11.5. If we got the derivative 7t to the 4 minus 7t plus 6e to the t, what is the derivative of that? Well, we know the derivative of e to the t is itself, so f prime of t should be 7 times 4, which is 28, t cubed. The derivative of negative 7t is negative 7, and then we get 6e to the t, so there is no change in that third term because the exponential derivative is itself. So the derivative of this particular function is going to be the derivative of the first piece. So we're going to identify x to the 5 as the first, and then e to the 6x as the second. So derivative of the first, so derivative of, well, maybe I'll use the prime notation. It would be a little easier to write. So x to the 5 prime times e to the 6x plus e to the 6x prime times x to the 5. The derivative of x to the 5 is 5x to the 4. So we can do that one relatively easily. Now, for this particular derivative, we can think about this as e to the u, where u is equal to 6x. So by the chain rule, we're going to get e to the u times the derivative of u, which is 6. So in this particular case, we're going to get e to the 6x times the derivative of u, which is 6. So we end up getting something that looks like, how do we write this? Maybe like 6x to the 5 e to the 6x, maybe something like that. We could factor this if we wanted to, if it was helpful. But in this case, we're just trying to find the derivative, so I think this is probably fine.
Zeta conundrum. Each channel has its own variables, but I'm here now. Focus on your current problem set. What's the next question in your life equation?
This is the next question in my life equation. We do have two pieces here for this first part. So this first part's going to be a little bit of a pain in the butt. But we're going to do something like 5x to the 7 prime times the times ln of x plus the derivative of ln of x. So I'll just write that like this. Times 5x to the 7. And then we need to take the derivative of 4/3 x cubed. So that's 4/3 3x squared. That means that these threes will eventually cancel, and we're going to get 4x squared over here. Now, let's go through, fill in the derivatives of the two pieces we need. So 5x to the 7, that's going to be 5 times 7, 35. So 35x to the 6 ln x. The derivative of the natural logarithm is 1 over x. So this is going to become 1 over x times 5x to the 7. So we're going to get something that looks like this. I mean, provided we don't really care about 0, which we don't because we have the natural logarithm in our formula. Anyway, we can probably simplify this to x to the 6. And then, like I said, we'll get 4x squared to finish off question number 3. Wow, we have a lot of product rules here. So this is another product rule, isn't it? So f prime of x is going to be the derivative of the first times the second plus the derivative of the second times the first. For negative 4x squared, so negative 4 times 2 is negative 8. So this is going to be negative 8 logarithm x plus, we're going to get negative 4x squared over x. We could simplify this. Again, I'm not super worried about x being equal to 0 because I have a logarithm here already. So I could maybe simplify this to just negative 4x, and that should probably do the trick here for part A of this question. Then they want us to evaluate this at e squared, which is going to be negative 8 logarithm e squared minus 4e squared. Is this 2? Is that 2? The logarithm of e squared, right? The logarithm of e is 1 because it's e to the 1. So logarithm of e squared should be 2. So I think we're going to get negative 16 So negative 8 times 2 minus 4e squared. So I think that's what we get here for a final answer for that secondary part. Differentiate the following function. You do not need to simplify the derivative. Okay, we could use the quotient rule, which is probably the way most students are going to do this, so maybe that's the way we should do this. So let's call this like the top, or I usually call this like high, right? This is high, and this is low, and h prime of x is low. D high minus high. D low over low squared. So low is x squared. The derivative of high, the derivative of high is e to the 8x times 8. I'm going to bring that 8 down because of the chain rule. And then we need high, derivative of low, which is 2x, all over low squared. So we could clean this up a touch. I would recommend cleaning it up just a little bit. I might write this as 8x squared e to the 8x minus 2x e to the 8x all over x to the 4. So I would probably go to here. There is a little bit of factoring you can do, but it's not super helpful with regards to just simple derivative questions like this. If we're doing something else, like trying to set this derivative equal to 0, maybe factoring's helpful. But this is probably good enough for what we need to do right now. But yeah, no, I got you, Jeff. Like, that's probably what I would have done in the last question. I probably would have moved the x squared and made it x to the minus 2 and used the product rule. It's far easier to do that. I mean, maybe it's worthwhile for us to do it anyway so that my students can see what you're talking about. But yeah, if you rewrite h and you rewrite it as e to the 8x times x to the minus 2, then you just have to apply the product rule. So h prime becomes the derivative of the first function, which we know is this, times the second function, plus the derivative of the second function, which is negative 2x to the negative 3, times the first function, which is e to the 8x. So another valid way to write h prime would be 8x squared e to the 8x minus 2x to the negative 3 e to the 8x. Did I do a bad? Oh, this is x to the negative 2. That's why. So this should be x to the negative 2 here. So I made a small mistake. That should be minus 2. And now I can see, right? Like this simplification is x to the minus 2. And then this simplification over here is that x to the minus 3. So yeah, so these two derivatives are exactly the same thing. One is just expressed in a fractional form, and one is expressed in this kind of subtractive form instead. Why does it say use exact values? That's weird. So f prime is going to be the derivative of this, which is e to the 7y times 7, minus the derivative of this second function. So I have to multiply this one by minus 7. So if I want to simplify, I get 7e to the 7y plus 7e to the negative 7y. And that should be our derivative of y. So I think one thing that's helpful to talk about here is if I have a function and my function is like a logarithm of something, then when I go to take the derivative of f with respect to x, what's going to happen is we're going to be taking the derivative of this logarithm with respect to x. And I'm kind of assuming here that u is a function of x, so that when I kind of pass this derivative through, we're going to look at, using the chain rule, we're going to get 1 over u, which is the derivative of the logarithmic function or the logarithmic part of this. And then we're going to be kind of distributing, but via the chain rule, that dx through. So we'll get a du dx. Now, if we write this du dx as u prime, then we really get 1 over u times u prime. So it's almost like saying u prime over u. So as long as you can identify what the function u is and take its derivative, then you can always find the derivative of a logarithmic function of something more complicated by doing that. So we're going to say that u is the inside part of this logarithm, which is x squared plus 10x plus 29. And we're going to say that the derivative of that with respect to x is 2x plus 10. So that our overall derivative for f should be u prime over u, which is, 2x plus 10 over x squared plus 10x plus 29. So some kind of cool patterns, I think, kind of arise when you're looking specifically at derivatives of the natural logarithm, because you don't have to multiply by that like weird log a business. Here we need to find the second derivative of this. So the first derivative of this is going to be 4. We're going to hit, oh, this is a tricky one. We might want to break this one up a little bit. So if we have f is equal to 4 ln of sine of x, we could say that this is f. Let's write this as 4 ln of u, where u is equal to sine of x. And so now we're in a situation like before, where I know that the derivative of f is going to be 4 times u prime over u. That's always what the derivative of the natural logarithm looks like with regard to the chain rule. So let's find u prime with respect to x. The derivative of sine is cosine of x. And boom, we can now just fill in all this information. We know that the derivative with respect to x is 4 cosine x in the numerator, and we need sine x in the denominator. And if you're savvy with your trigonometric functions, this is what? This is a cotangent. So we could write this as 4 cotan of x. That would work.